All right. So probability. So chapter 9, we're looking at probability. Probability. And the reality is we use probability every day in our lives. Now, you don't necessarily put numbers into a formula and get out your calculator and calculate the probability of something. But in terms of thinking, we think about probability all the time. And even without thinking about it. Excuse me. For example, you plan to get up this morning. Maybe some of you have an alarm. You were probably thinking that there's a pretty good chance that there's not going to be a power outage overnight and that your alarm is going to work and it's going to wake you up on time. That's a pretty high probability that that's going to happen, right? That your alarm will wake you up in the morning. A pretty low probability that, maybe you get some sad news or something in the morning and you don't end up going to school. Pretty high probability that at some point during the day, you will see the sun in the sky. There would be a pretty low probability that you get to school and you don't have any of your materials and you forgot everything at home, right? Well, wait a minute. For some of you, I guess that would be a pretty high probability. But generally, that's a bit of a poke. I'm just joking. But generally, you guys come with your books and your pencils and your calculator. You generally have everything. So if I'm asked to kind of assess, how many students will come with everything, in their binder today, they'll have their book, their pencil, their paper, their everything. I would guess the probability to be pretty high. Okay. So we think about probability all the time. It's raining today. Okay, if you looked at the forecast, yesterday, you probably planned to have some kind of rain jacket. I brought my rain jacket over there. You probably planned for an umbrella, to bring an umbrella maybe, because when you look at the weather forecast, it says there's a 95% chance of rain tomorrow. You're thinking, that's a pretty good chance that there's going to be rain tomorrow. I should plan for rain. If you look at the forecast and it's 0% chance of rain and it's just the sunny sun symbol, you're thinking, I'm probably not going to bring my umbrella to school today because it's not going to rain, I won't need it. So even if there's official probabilities like the forecast of rain, that's official probability maybe, but unofficial probabilities all the time. Okay. So what you will learn today is understanding the role of probability in society. We just talked a little bit about that in our life. Address problems related to data collection. So when we assess probability, we have to collect data a lot of times, because if for the weather people to say there's a 95% chance of rain, what they've done is that they've collected data and they have their meteorological models, and they say, oh, when the humidity is this high, when the wind is like this, when the pressure is like this, it rains most of the time. So we'll tell everybody that 95% of the time that all of this has happened before, it's rained, so you guys could probably plan on rain happening again. So, but there's problems and there's issues related with collecting data as well. To use population or sample data to answer a question, we'll talk about the difference there. And to develop and implement a plan to collect, display, and analyze data. So the other part of this chapter is statistics. So again, measuring things, looking at what are the stats. Okay, you guys know about stats, right? Lots of times we hear that in sports. Okay, what are your stats, or what are the stats on that last game? How many rebounds did you get, or how many goals did you score? Those are statistics. And so collecting that data is important. So there's some key vocabulary terms that we'll run across as we move through. Okay, so let's get into it. Chapter 1, probability in society. So outside of the classroom, I don't know if you guys can see that. Thanks for dropping those lights. So probability outside of the classroom. What kind of things do we use outside of the classroom and formulas and textbooks in this room? Well, we talked a little bit about that. Let's start off by saying that probability is a measure or the likelihood of an event to occur. And we have a fancy name for, it raining, or you being able to make your next free throw, or the probability that I'm going to, wake up in the morning. Those are events. So we talk about that in terms of an event. So the likelihood of an event happening, or what are the chances that this is going to happen? Okay? And it can be expressed in several ways. So obviously a percent, as I mentioned, the percent of rain today, or precipitation, that's one way that probability can be expressed. It can be expressed with mostly words, some words and numbers there, like 4 out of 10, okay? Or a fraction, 4 over 10, or a decimal, 0.4. Those kind of all mean the same thing, and I will zoom in just a touch here for you at the back. So those all mean the same thing, all right? And there's lots of different ways we can express that. So let's get some practice here. You guys did an activity, I think yesterday in this class. You did some Kahoots on probability. What's the likelihood of this happening? What are the chances? So you kind of have a little bit of an idea about this already. And if you weren't here or you didn't get a chance to do that, there's links on my website there that you can do those. Take a look at those Kahoots sometime if you want. So from the statements below, identify the different probabilities used, list an assumption, and there might be many, associated with each statement. Okay. Now assumptions are important because when we make predictions or talk about probability, we are assuming lots of things. So we want to be aware of those assumptions. Okay, Jean-Guy noticed that in the last month, 70% of the time the bus was 3 minutes late. So 77 out of 10 times the bus was late for 3 minutes. So he takes his time with breakfast today. Okay. So identify the probabilities. Well, you're talking about the probability that the bus will be on time, right? So you want to highlight that or write that down. 70%, okay, that the bus will be, the bus will be late, okay? 70%. 7 out of 10 times bus is late by 3 minutes, right? And now, importantly, what are the assumptions associated with that? So Jean-Guy assumes that what? What does he assume? Okay, the bus is going to be late again. Yes, he assumes the bus is going to be late again. So we can write that. That's one major one, I guess. We're going to dig deeper in that one, but Jean-Guy assumes that bus will be late by 3 minutes again. Okay, why? So he assumes that the bus will be late today. Now, the obvious answer, I suppose you're all looking at me like strange, like why did I ask that question? But 7 out of 10 times, that's more than half, right? So the likelihood is fairly high that it'll be late again. Now, it could be early because one of those, 3 of those times out of 10, the bus is either on time or early, so he could totally miss the bus. So he's taking a bit of a risk, right? But he's assuming the bus will be late today. The other assumptions, and it's important for us to dig a bit deeper here, I think he's going to assume that the conditions of the bus route are the same that they normally have been, or their average conditions, right? He's assuming that let's say that the traffic is its average in an average traffic day. So let's say he's assuming that the traffic is the same as usual. He's assuming that the bus is working well and not broken down. He might be assuming the same bus driver even. Same driver. He might be assuming that there's the same number of people getting on and off ahead of him, right? All right? And there may be many more. He's making all these assumptions because he's kind of balling it all into one, right? It's like, okay, well, maybe traffic was heavy a couple of those days that I've noticed the bus being late, and maybe it was light a couple of those days. So those maybe will average out. I don't know what it's going to be today, but I'll just assume that this 70% is a good picture of today, because I'm assuming that all the other things are the same. So those are just some examples. Can you think of anything else that's not on that list? Other assumptions?
Traffic.
Okay, traffic. I mentioned traffic. That's on there, but that's okay. Yeah, traffic. That's okay. So, you could be writing some of these down too. I don't know if you have this down, but you should be writing some of these down that I write up here. He's also assuming that it's going to take him the same amount of time to get to the bus stop. I don't know where the bus stop is. Like for me, the bus stop is a few blocks away from our house. We don't have a bus stop just right outside the door. So you can be assuming that it's going to take him the same amount of time that it normally does. Okay, let's do a different one here now. So B, at school, Jean-Guy and his friends agree that their lacrosse team has a 95% chance of making it to the finals. Okay, so what kind of, obviously the probability there is making it to the finals, right? Okay. Making it to finals, fine. That's the probability. There are lots of assumptions here. So they are assuming that. What kind of assumptions are they making? Yeah.
They'll have a full roster and that no players will be injured.
Very good. Full roster. Okay. So that's no injuries. Good. Because that obviously really affects things, right? Okay. What disappeared? Full. Yeah, full. I don't like it when things disappear on me. Okay. Other assumptions? What else? Yep.
Maybe like wins.
Wins?
Yeah.
Okay. What do you mean by wins?
Like just like the amount of games they need to like make it to the finals.
They've been like, oh, so that team's not very good. We'll probably beat them, and then they just kept assuming. That
Okay.
teams.
All right. So 95%. Okay. So let's just say other teams haven't changed either. Other teams haven't made any major changes, right? A painful memory I have. My son was on a basketball team, and he was on the junior boys team, and they were killing it all year. Like they were top of the league all year, and then they get to the finals, and this other school, they had like 3 players that all of a sudden were in their lineup that hadn't been all year, and our team lost, and it was like, so they were going in there assuming that they were going to be able to win this. And then all of a sudden they had these 3 ringers. They were students, I guess. It was all legit, I guess. But there were students that hadn't played all year, and then they lost. So it's like, yeah. So they were making an assumption that the other team hasn't changed their roster a little bit. Okay. Yep. Okay. So are there any others that are not on this list that you thought of? Those are 2 pretty main ones, I would say. Yeah. The team hasn't changed. The other teams haven't changed. I guess even an outside, like a big wide assumption that the season isn't going to get canceled for some unknown dumb reason, right? So that the playoffs will actually happen. Now that is an assumption, although you don't really think about that, right? Oh, a meteor might hit the Earth before the finals, right? So I mean, there are other like big ones. So if I said give 3 assumptions on a test, you can kind of like, please hit some obvious ones, like these are obvious ones. But I mean, if you're really struggling for a third one, it's like, well, they're assuming that they're going to be alive for the finals to enjoy this, maybe, or that their whole team is going to be, around, that the meteor hasn't hit the Earth or something like that, that the finals are actually going to take place this year, the season is going to get canceled. So you can kind of use your imagination a little bit if you're scratching for some. Don't make all of your assumptions like that. They might all turn into, piles of jello or something. It could happen. The laws of physics might not actually, work tomorrow. So we all might explode because the atmosphere might fly away from the Earth. I mean, so stuff like that, I appreciate your imagination, but let's make some of them at least grounded in reality. Would that be okay? Yeah. Okay. See. Lately, Jean-Guy's math teacher checks homework 4 days a week. So Jean-Guy makes sure he has time to complete his homework for today. Oh, look at that. Isn't that a good teacher move, to make sure you actually check homework so kids are aware that you're gonna maybe do that today? So Jean-Guy is assuming that what? There's lots of assuming. Okay, so I won't write down the probability, but obviously that the teacher's gonna check homework, okay? And what is the probability as a number? Let's jot that down. 4 days a week. So what's a school week?
5 days.
Yeah, so that's 4 out of 5, right? That he checks homework, or 80%, okay, of the time the teacher checks homework, okay? So that's our assumption. That's our probability there. Now, if you said 4 out of 7, you wouldn't get full marks on a test or a quiz on that, really, right? Because you don't go to school
6 days a week.
you don't go to school 7 days a week. Yeah. So no, if you said 6 and you explained, hey, where I come from, we go to school 6 days a week, because that is the truth somewhere, you would have to explain that, and I would probably give you full credit. If you were from another country that went to school 6 days a week and you said 4 to 6 because, okay, great. If you just said 4 to 6 with no explanations, good chance you're not going to get full marks, okay? The probability is low anyways. Let's just say that. You're going to get full marks. Okay, some assumptions. What are some assumptions? Okay, yes, the teacher will be there. Yes, exactly. That's the one I thought of first. That the teacher will be present. Now, if the teacher is not there, now that's all out the window, right? Because you don't know what kind of substitute you're going to get. Maybe the sub comes in and doesn't know about the homework checking procedure and doesn't check homework. Or maybe the sub comes in And, you know, it's a new teacher, it's a young sub, and they want to make sure they cover every basis. So guess what? There's homework that was supposed to be done for today. So they see it on the list, and I'm checking homework. I'm going to make sure I dot all my I's and cross all my T's, and I'm going to do a great job. So maybe it's 100% with this sub that you're going to get checked, right? Or maybe it's 0. You got a guy coming in and like, I don't know, I have no idea. You didn't email me the plans. I don't know, what are you guys doing? What class is this? Is this art? And of course you would say, no, this is math. You wouldn't say, yeah, it's art. We're supposed to be drawing pictures of Mickey Mouse today. Don't get any ideas. Yeah. Because guess what? I would find out about that. Yeah, they said, art class went well. Here's all the pictures of Mickey Mouse they drew. Oh, would you guys be in trouble? Okay, so yeah, the teacher's present. The teacher's present. Anything else?
Students going to be present to give them the homework?
The students are going to be present to give them homework. Okay, well, the students being present to get the homework probably would have happened already. So that's a bit of a different thing. I mean, to get homework that day, I mean, I don't know what you're saying really, but the homework that would be checked would have been assigned previous. Okay, so this student has the homework's already been assigned, right? See, has time to complete his homework. So the homework's already been given.
That class won't be canceled?
That class won't be canceled. Sure, absolutely, because of said meteor, right? So we're assuming that class will happen. Absolutely. That there won't be a fire drill. Ooh, no fire drill. Or something like that, you know. Lots of stuff could happen, right? Okay. Yeah, very good. If fire drill happens, you know, in the previous class, just at the end of the previous class, guess what? You come back in, there's only 15 minutes of your class left, or you might not, teacher might not have time to check homework. It's like, yeah, listen, I'm just going to teach you this for 10 minutes, and then we're not going to do homework check today, right? So, okay. Finally, I'm going to let you guys work on this on your own, and I'm going to ask you for some of your answers in a few minutes. But in health class, young guy's teacher reads a magazine that claims that 172 out of 1,000 male smokers develop lung cancer, but only 13 out of 1,000 males who do not smoke develop lung cancer. Okay, so the probability is contained right here, and right here. There's 2 probabilities involved. So you want to write those as a decimal, please. Write those as a decimal, okay, as a decimal. And because we haven't done that exactly, I'll do the first one for you. So 172 divided by 1,000. When you divide by 1,000, actually it's really easy to do. You just move the decimal place of the original number to the left 3 times. So that is 0.172. Okay? You can do that kind of stuff without a calculator. So you move it to the left 3 times. Now, as a percent, that is 17.2%. Because we take the decimal and multiply it by 100, and when we multiply something by 100, we move the decimal place to the right 2 spots. So 17.2%. Okay, I'll let you finish that as well as a list of some assumptions, please. Okay, go ahead, take a couple minutes and give that a try. I want to see what you guys come up with. So the percentages we talked about here, 17% of smokers develop lung cancer, 1.3% of non-smokers develop lung cancer. Some of the assumptions that you guys have mentioned, that there are no special outside factors in health, maybe something another type of cancer that the person would normally have developed, or you know, that maybe spread to the lungs, that kind of thing. Age, okay, what are the age of these people in the survey here, or in the data group? The truth of the advertising, which is something that we really need to pay attention to, because advertising the truth can be stretched a little bit and mangled just a little bit to serve purposes, so we do have to be careful with that. The time people in the survey have smoked, 30 years versus 1 year, or how many times a day they smoke, or how many packs a day or a week or whatever. So yeah, these are all good assumptions. And yeah, we don't know some of these details, but you can be rest assured that smoking's not good for you, okay? So please don't take that habit up. All right, let us continue on. Okay, subjective judgment. That's a big word, subjective. I think you've probably heard of that before. Okay, you guys have this on page 2, right, of your notes? Subjective judgment, okay. So what does subjective mean? It might be on the page there somewhere, but first thoughts, what does it mean to you? Anybody? What's the opposite of subjective, or what is it usually compared to? Objective, right. So what is subjective versus objective? Okay, very good. So subjective is usually like an opinion, maybe, and objective is maybe more like an established fact. Okay, yeah. So subjective, the statement depends upon the subject, who's giving it, what kind of biases they have, what kind of feelings they have towards it. It's a little bit more opinionated, good. And objective would be, the other type that's a little bit more data driven, maybe a little bit more removed from emotional or personal biases. So when you flip a coin, there is a 0.5% probability. That's not right. There is a 5% probability. And the decimal, we could probably put that in brackets, 5%. 50% probability. Not at 0.5%. It's 50% probability. So you can actually change that. I will probably make that into a bit of a blank for the notes next time. That the coin will land heads up. Okay, despite this probability, you may feel strongly that the coin will land tails up. In this case, you have made a subjective judgment. So again, based on your opinion, that's a subjective judgment. Okay, the objectivity of this situation. There's only two options, heads and tails. So if there's only two options and you get one of those two options, that's a decimal of 1 out of 2, or 0.5 as a decimal, or 50%. Okay. Theoretical probability. This probability is based on reasoning, and also based on the reasoning specifically from past from, like, I should say, the nature of the situation. Okay, so from the nature of the situation. For example, as I mentioned, a coin has just two sides. They're the same size, same weight. We would assume that 1/2 of the time it would land on heads and 1/2 on tails. So the theoretical probability of rolling a heads would be, as we mentioned, 50%. Okay, that's the theoretical probability. That's the theory behind the situation. It's because of the nature of the situation. So technically, theoretical probability is defined as the number of, this says favorable outcomes, and this is kind of math terminology that you'll see all through high school. Favorable outcomes, and in this case it would be, heads, okay? Divided by, so the number of favorable outcomes divided by the number of total possible outcomes. That's what theoretical probability is. That's where we get 1 out of 2 for this example. The other example they say here is, what's the probability of rolling a number greater than 4 on a standard die? Well, on a standard die, you have 1, 2, 3, 4, 5, and 6. Those are the only options. So to get a number greater than 4, you would have to consider 5 or 6. That's 2 options out of a total 6, or 1/3, which would roughly correspond to 33.3%. 33.3%. Okay. Any questions about that example or what theoretical probability is? All right. What's the theoretical probability that you are in this room right now, physically? 0? Or 1? Okay. There's one favorable outcome that you are in this room, and because you can't physically be in 2 places at once, the total possible outcomes is also 1. So 1 divided by 1 would be 1. Okay? Now, if you were elsewhere in your mind thinking of what you're going to do this weekend, then that's a different question, isn't it? Okay, hopefully you're all here mentally as well. Okay, keep going. Experimental probability. Okay, so this is the big versus for theoretical. There's theoretical, the nature of the situation. Experimental probability is based on experiment. It's really easy to remember this one. So it's based on past physical experience. Okay, based on past physical experience, or based on experiment. For example, if you were to flip a coin 100 times and 46 times it was heads up, then that means it was 54% tails, which your experimental probability would be different than the theoretical probability. Now that happens sometimes, okay? That happens sometimes. The only way that you can be 100% sure that your experimental probability will match your theoretical probability is if you tested this thing an infinite number of times. If you did this an infinite number of times, then the experimental probability would approach the exact theoretical probability, okay? Which means that the more times you flip the coins, more than 100, let's say 1,000, let's say 10,000 times, that experimental probability should, by nature, start to get closer and closer to the theoretical probability. But when we just flip a coin twice, we could have heads up twice, right? And you couldn't say that, oh, this coin is rigged. This is a bad coin because it's weighted wrong or something's wrong with it because it's 100% heads every time. Okay, well, if you've only done it twice, you know, that happens, right? That happens sometimes. Okay, so there's a difference between theoretical and experimental. Any comments or questions on that? Based on experiment. Anything to say or ask? All right. Explain how each decision is based on subjective judgment, theoretical probability, experimental probability, or a combination of these. Okay, so let's take a look at these examples. In Ozma's experience, it is Ozma's experience that 4 out of 5 times the prize in the cereal box is found at the bottom of the box. So Ozma opens the bottom of the cereal box to find her prize. Ozma experienced that 4 out of 5 times the prize was at the bottom. This is based on what? Is this based on the nature of the situation, how prizes are naturally put into boxes, or is this based on primarily on her experience? Yeah, this would be experimental probability because she has personally experienced this 4 out of 5 times. That's what she's basing it on. Okay. Now, it's raining outside. Okay. The forecast isn't always right. So guess what? If I looked at the forecast and they said it was 80% chance of rain today, it could be that based on my experience, they're never right. Never right. It's never right. So I'm going to plan for no rain today. I'm not going to bring my umbrella or my rain jacket. I'm going to wear shorts. Okay? So that would be experimental. And that would be some subjectivity there, I guess, on my part, right? Okay. So subjective judgment, do you think, is this based on her personal opinion too a little bit? Yeah, maybe. I would say that experimental probability would be the primary answer there for sure. Okay. All right, next one. All right. So B, 2 friends are rolling a die. Now, you know dice, that's plural, that's 2 or more, dice. Die is just 1. You know that? It sounds funny, but die is 1. As well, data is plural. Datum is singular. So if you have a bunch of data, it's actually, you should be referring to that as plural. So the data are saying this. It's kind of weird. Anyways, 2 friends are rolling a die. Out of the 8 rolls made, a 4 came up 7 times. Wow. Ameth predicts that the next roll will not likely be a 4 since each number has an equal chance of being rolled. Maria decides that the die is unfair since 7 out of the 8 rolls reveals a 4. Okay, so get everybody figured out here. Ameth and Maria. So Ameth knows that the probability of rolling each number is 1 out of 6. His prediction is based on what? Is that based on the experience, the recent experience, or on theoretical probability, or what? What do you think? Yeah, I would say his would be theoretical. Ameth that's based on theoretical probability. Theoretical. Okay. Good. Ameth is based on theoretical. And Maria has noticed that the experimental probability of rolling a 4 is 7 out of 8. She knows that each number should have an equal probability of being rolled, but she makes a what? Yeah, she makes a subjective judgment. Subjective judgment. Judge. That the die must be unfair. Now, that's not unfair, I don't think, to state that. I think that is a fair statement that something could be wrong with with those dice, right? But theoretical is, hey, I know that this should happen because of the nature of the situation. Subjective judgments come into play when you have a feeling about something, or it's like, hey, you know what? I think that something's wrong with these dice. I'm going to make an assumption that is based on my subjective feeling or experience here. All righty. Is this the last page? Ooh, last page. Let's see if we can get this done. In the past baseball games, Alice made 2 hits for every 5 times she went up to bat. That's actually pretty good. That's a 400 batting average there. I like it. In the next game, suppose Alice goes up to bat. What's the probability that she will hit the ball? And what assumptions are you making? Okay. So what's the probability she'll hit the ball? Well, it says right here, I guess. The probability she'll hit the ball would be based on her batting average, they call that. 2 hits for every 5 times she went up to bat. So the probability is going to be about 40%. Now, in baseball terms, those of you that know baseball, they usually write it as a decimal like this with 3 decimal places. And this .400 is a 400 batting average. They just say a 400 batting average because everyone knows what they're talking about. It's .400, or that's 40%. So if you're batting 1,000, and I was a baseball player, if you're batting 1,000, that means that you have hit every single you've hit every single time you've been up to the plate. So you're batting 1,000. That's really good. Nobody has that average over the whole year, but somebody might have that average in a game, right? You're up 4 times and you had 4 hits. Awesome.
What's your best average in a game?
Oh, I don't know. In a game? Oh, I think I've batted 1,000 in a game before, for sure. I haven't played baseball for a long time, though. Yeah, it's been a long time since I've been on an actual team. Okay, what are the assumptions? So what are the assumptions? Yes, there's lots here, probably, but let's knock off a few. Go ahead.
That the wind kilometers per hour is the same.
Oh, wow, we're going pretty detailed right away. Wind speed, I like it, yes. Okay, so the wind speed, I would dare say we could assume that the direction is not really wacky. Maybe it's not a complete direct side wind or that's going to help the curveball or something like that. So wind speed, direction, etc. Okay. Now, it is probably safe to assume that there were varying wind speeds and varying wind directions on the previous experimental data, right, that have been gathered. So, yes, but it could be like this totally blustery day. You could have 100-kilometer-an-hour wind on this day, and, you know, it's crazy, right? Totally get it. That's perfectly valid. Anything else? What else?
Like she's feeling the same as the last
Okay. So she feels the same. She's healthy, let's say. Healthy and feeling the same. I like that. So that the girl here, Alice, is healthy. Anything else? Another couple? Yeah.
She's using the same equipment.
Okay, same equipment, same bat, and all that sort of stuff. Okay.
atmosphere would be the same.
Okay, that's a good one. The atmosphere. Now, how many of you know that when you're playing at home, if you're playing a sports game at home, you're a little extra jacked up, the adrenaline's going. Sometimes you can do things that you normally wouldn't be able to do if you were feeling like, oh, I'm in the enemy territory, like sometimes your mind plays tricks on you. And so the atmosphere, yeah, atmosphere. Okay, good. And yeah, another one. Okay, so let's just say that it's a typical or an average maybe pitcher that's out there. Let's say the pitcher is not this phenom that all of a sudden joined the team, right? So let's say opposing pitcher and stuff. Okay, these are all great. Opposing pitcher is is relatively average. Okay, is sort of average. Okay, good. Okay, explain how you predicted outcome or the predicted outcome might change if the assumptions change. So if she's playing a team that's more skilled than the teams that she's played in the past, what may happen to her batting average or the probability that she'll get a hit that game? Yeah, if the team that she's playing is more skilled, then the average might go down. Okay, average might go down. Excellent. I mean, which isn't excellent for her, but now, am I seeing this wrong, or does she have some kind of like cross grip there?
What?
No, I guess I'm not seeing that right.
She's got a glove on, so you can really see her hand.
Yeah. Okay. Yeah, does that look weird to you? Looks like she's got a pretzel arm right there. I'm not sure. Something looks okay. Yeah, no, that it just looks like really weird. Okay, yeah. Oh, I guess the problem is usually you have the glove on the bottom hand,
You can't see it.
not on the right hand, but not on the top hand. But anyways, okay. Can you guys even see that in your copy? Okay. So usually you have the glove on the bottom hand. I don't know.
See it. Not really.
So there's a glove on this hand and that.
But you don't hold the
Now it's got me thinking here. I'm not a right-handed batter. She's a right-handed batter, but so she's got her that arm's on the bottom, so that is a proper grip. But just that picture looks really weird to me. Okay, I'm left-handed this way, so it's this arm goes on the bottom. Yeah, pretzel arm. Okay, woo, that's a little bit of a brain break there. Okay, so let's get back to math here. So more skilled team, average goes down. Okay, if she's playing a team that's less skilled, maybe they don't have great pitching. What happens? Average goes up. I would say that's, probably average would go up because the conditions have changed, the assumptions have changed, the experience is going to change probably a little bit. Okay, that's excellent. Any questions about that? Other than us critiquing her batting approach there. Anybody? No. All right. Okay, this is the last example. Let's fire through this one. Example 4. John wants to learn how to snowboard, but he does not want to take lessons. Okay, his mother insists that John take lessons. John and his mother find an article that claims 68% of snowboarding injuries occur during beginner lessons. Ooh, explain how both John and his mother can use this statistic to support their opinions. Okay, now there's a reason for the two opposing sides to use this exact same piece of statistic here for their own side. Now let's think about it from both perspectives. John could argue that what? This one might be a little more obvious, I'm not sure, but go ahead. What do you think? Yeah, he could argue, hey mom, listen, more often than not, people that take classes get injured, man. I don't want to get injured, so I'm just going to avoid the class. I don't know if John would talk like that, but I'm assuming John might talk like that. A little bit like snowboarder, man. Like, I'm a surfer in the summer, I snowboard in the winter. If you're from California, I apologize. That's a mocking, but anyways, okay. So still on John here. Anybody else want to say anything about John? Okay, so let's just copy that down real quick. I think on the surface, that's an obvious argument, right? Wow, that's pretty high. That's almost 7 out of 10 people that take beginner lessons have injuries during their beginner lessons. I don't want to take lessons if I'm going to get injured 70% of the time. Okay.
Grade 4 to 8 will be indoor recess. Grade 4 to 8 will be indoor recess.
Okay, any comments on John still before we move on?
that it costs money.
Okay, another he could argue that the lessons cost money. Let's also save some money. Good. I'm going to keep the comment here to the 68% so that we're just talking about that. But yeah, there are other assumptions and other factors. That's excellent point. Yes. Okay, what if the statistic is made up? Okay, I think we're also assuming that the statistics are legit. That statistic is legitimate, okay? But very good. I like how you guys are thinking, okay? This is critical thinking. Now, let's move to John's mom. What's the argument from John's mom's perspective? Or is there even one?
Well, you probably won't even know how to use it, and if you could get injured more.
Okay, so if he doesn't know how to ski, his injuries later could be greater. Okay, that is a very good one. Yes, I like that. Are there any other ones that are different than that?
Well, it says 68% of it happens during beginner lessons. So he said, oh, it's because of the lessons, but his mom could be like, it's because he's a beginner.
Okay, and the mom could say, just hang on, we're not going to go yet, just hang on. His mom could say, it's because you're a beginner that you get injured. It's not necessarily the lessons. It's just because beginners often get injured. Yes, I like that as well. So I'm going to quickly jot those down, and I want you to before you leave here. All right, so beginner lesson injuries are not as severe as injuries of people who don't take lessons. So you may as well have a slight injury on the bunny hill instead of having an injury on the black diamond when you don't know what you're doing. And also, injury rate is due to being a beginner, not because of the lessons themselves. So go ahead, you guys can be dismissed. This is your assignment. I will give you some time tomorrow to work on this assignment. God bless. Be safe on the slopes.